Hello friends, welcome back again to my class today. In our lesson today, we are looking at theory of logarithms, or you call it laws of logarithm, okay? With the laws of logarithm, we are going to simplify all these questions we have here on the board. Not just this. In my subsequent videos, I will solve more problems. All you need to do is to subscribe to this channel and put the notification on so that whenever I upload a video, you are notified. So sit put as we go into the lesson. The first law of logarithm we are looking at is the multiplication law. If I have log m times n, two terms multiplying themselves, we can split them into two logarithms with addition sign in between them. All right, you have this, split them into two, log m plus log n. For an example, I have logarithm of, let's say 36 base 2. You know that 36 can be split into 18 times 2 base 2. And this is equal to logarithm of 18 base 2 plus the logarithm of 2 base 2. We have succeeded in separating the two terms of this logarithm into two different logarithms with addition. Then the next we consider is subdivision law. I have logarithm of m. Let's assume we are using base b. And this guy is divided by n. Log m over n, okay? We can split it into two different logarithms using subtraction sign. M log m and then n for minus log n. For an example, if I have 35 over 18, let's say base 3, we can split it directly to log 35 minus log 18, both in base 3. Then you can take it up from there and simplify. By the time we start solving examples, you see how to apply these things in solving examples. Then let's consider the next one. In this one, we are looking at the power index law. If I have m raised to the power of a, let's say base b, the law says that a comes to the front. So what are we going to have? A log m base b. From here, you can simplify. Let's consider an example. If I have logarithm of 8 to base 2, you know that 8 can be written as 2 raised to power 3 base 2. That is just to make the base and the log term to become equal. Then this power can now come to the front such that we will have 3 logarithm of 2 base 2. You take it up from there. Let's consider the next law. Any logarithm to its base is equal to 1. If I have logarithm of m, which has a base of m, it is equal to 1. An example, log 10 to base 10 is equal to 1. So that means what I have here is 1. Any logarithm, even if it is log 3 base 3, it is still 1. Okay? Then the next we are looking at is logarithm of 1 to any base is equal to 0. So anytime you have logarithm of 1, no matter what the base is, that value is 0. For instance, logarithm of 1 base 2, what I have is 0. Then the sixth law we are considering is change of base. If you have logarithm of m and n as its base, you can change this base into a natural base of 10 and use this base here as the number of another logarithm in division. Look at what I mean. I'm going to have logarithm of m base 10 over logarithm of n base 10. With this, we'll be able to simplify this function. We normally do this when you have logarithm of numbers that the base cannot permit you to simplify. A very different base, and this number here cannot be reduced to look like this base. We apply change of base and solve it. Most times, we get our value as decimal numbers. Let's consider the last one before we go over to solving these problems. That is the seventh one. That is what we call relationship between indices and logarithm. Sometimes you have logarithmic equation log m base b equal to x. And you cannot simplify this using logarithm except you change it into indices. So what do? Your m, the log term, will become the subject m equal to b becomes base the subject becomes power. So more or less, we use b to make x the index of this function or equation. Once you have done this, indices can now simplify the given function. And whenever you are given indices as well, you can use logarithm to solve when indices cannot simplify that given indices. Let me show you what it looks like. I have logarithm of 8 base 2 equal to x. So to simplify, 2 will carry x. I'll now have 8 to be equal to 2 raised to the power of x. Then 8 can be written as 2 raised to the power of 3 equal to 2 raised to the power of x. Since the bases are equal, that means the value of x is equal to 3. So this is how we relate indices to logarithm. We shall be making application of this in our next video, where we'll be solving equations that have to do with logarithm. Sit tight and relax. We want to go straight into the solution of these problems. To solve number 1, we can also write this as 49 over log 343. Please don't apply the law of division here to simplify this, because this is way different from division law. You remember that law of division says if you have log m over n, this is only when the logarithm terms are dividing each other. But when you have logarithm of m divided by logarithm of n, don't use subtraction to solve. Go ahead and divide them, okay? So from here, I'm going to have log 7 raised to the power of 2 over log 7 raised to the power of 3. This is writing 49 as index and 343 as index. Now from here, 2 and 3 will come to the front of the logarithms. So we are going to have 2 logarithm of 7 over 3 logarithm of 7. Now, logarithm of 7 will divide logarithm of 7. We are going to have 2 over 3 remaining. So 2 over 3 is the solution of this first question. Let's solve the second one. In this case, we are going to make use of that division law, okay? Whenever you have subtraction of 2 logarithms, you can bring the 2 logarithm terms together by dividing the both of them. So 8 and 4 will divide each other. So we have log 8 over 4 over, same thing happens here. We have subtraction, so I'll have logarithm of 4 over 2. 8 divided by 4 will give us 2. So we have logarithm of 2 over 4 divided by 2 is 2. So I'll have logarithm of 2. Logarithm of 2 divided by logarithm of 2 is giving us 1. So the solution is 1. This is just like when you have x over x. X divided by x is giving you 1. Okay? Let's solve the third one. Here, I will reduce 4 to its index. That's 2 raised to the power 2 plus, do the same thing here, log 2 raised to the power 2 minus, the same thing here, log 5, then 5 raised to the power of 2. So having reduced to the index, all the powers should come to the front, all of the powers. So for here we'll have 2 log 2 base 2 plus. Now, since the base is what have the power, we are bringing it to the front as the reciprocal of the power here. The reciprocal of 2 is 1 over 2, because denominator of 2 here is 1. Reciprocal means rearrange them so that denominator comes up, numerator goes down. So let's take the reciprocal of this guy to the front. That means we are having 1 over 2, logarithm of 2 base 2 minus, the same thing will happen here. This power comes to the front as the reciprocal, 1 over 2 logarithm of 5 base 5. Now, remember the law of logarithm that says that logarithm of number to its base is 1. So what I have here is 1. 1 times 2 is 2 plus logarithm of number to its base is 1. 1 times half is half minus 1 times half, half. Okay? So half we minus half to give us 0. Bring down 2 as your answer, because these two will subtract each other. So this is the solution to the third question. At this point, we are coming to the end of the class. I will leave you to try yourself with question number 4 and question number 5. Drop your answer in the comment section. I will see it. But in my next video, I'll be solving more questions on logarithm, simplification of logarithm. In that video, I will also be solving the correction to this assignment. Thank you for watching to the end. Please like this video, share it to your friends, and subscribe for more interesting mathematics tutorials. Don't forget to put the bell icon on so that whenever I upload my useful mathematics tutorials, you will be notified. Thank you so much. Catch you up in my next video. Bye.